Hello students, welcome to an academy. Your KP sir on live. We are discussing regarding hydrology, AE, AEE. Already we have finished 7 sessions in the last month. This month we'll complete the entire syllabus. Now today we are going to take the continuation of the topic, previous topic. So is everything clear? Video and audio, is everything clear? Shall we move on? Before going to start the session, I have a small announcement. We are going to launch a new batch of GATE and ESC Civil Engineering. Myself, I am going to start Environmental Engineering from 29th September. This 29th September onwards, we are having a new batch of GATE and ESC Environmental Engineering. And also from 25th onwards, Geotechnical Engineering started by Rafi sir, Abdul Rafi sir. And 1st October onwards, RCC started by RP sir, Rajendra Prasad sir. So that new batch is going to commence from this month end. Take your plus subscription as early as possible. And so you will get a free study material, free online test series. And also very important thing, you are going to watch the classes. How many number of times you like, that many number of times. No issue regarding it. Ours is not a recorded session, it is a live interactive classes in an academy. So remember the date 29th onwards, we are going to start live interactive classes, a new batch of GATE and ESC. Now the session is related to hydrology for AE and AEE. Already we completed till evaporation session. Now evaporation measurement is remaining with us. Pan measurement of evaporation. Actually, evaporation is measured using various instruments. We discussed about it in the previous session. Measurement of evaporation. Good evening, Vasanta. So before going to start pan measurement of evaporation, first I will write down what are different methods of measurement of evaporation. Measurement of evaporation. Measurement of evaporation. It is carried out by three methods. One is instruments. Pan measurement of evaporation comes under this instruments. Instruments to measure evaporation, we can classify into two categories. We can differentiate the instruments to measure evaporation, two categories. Atmometer evaporimeter. Atmometer and evaporimeters, two instruments. This evaporimeter itself, we call it as evaporation pan. Evaporation pan and atmometer both are same. Evaporimeter both are same. There is no difference. Evaporimeter, evaporation pan, both are exactly same. Second method of measurement of evaporation, empirical equation. Empirical equations. So remember the empirical equations, consider them as, empirical equations will consider them as, you just remember the words, Fitzgerald equation, Fitzgerald equation, Rover's equation, Penman's equation, etc. We have so many names of empirical equation which are not practically considered. So always we follow evaporation pan measurement. the most important method of measurement of evaporation is a evaporimeter or evaporation pump. Other than this, we are having balance equations. We have balance equations. What are balance equation we are having? Balance equations include water balance method, energy balance method, and also mass transfer or mass balance method. So these are the different methods of measurement of evaporation. For our competitive examinations, atmometers is a failure instrument, empirical equations are not at all asked, and the water balance equation is required for GATE and ESC. Energy balance equation also needed there. Mass balance, again we don't have any much questions. So most of the questions related to pan measurement of evaporation. Asutosh Singh, you can write down while I am teaching. Asutosh Singh, while I am teaching the class or after completion of the class, you can go through once again, no problem, YouTube session. So you can write down, by watching the lesson, you can write down the notes, Asutosh Singh. Okay. So pan measurement of evaporation. Now our target. Now our target is about evaporation pan. This evaporation pan we also called as, what we also named it as evaporimeter. Evaporimeter, evaporation pan. Is it an instrument, automated instrument? Any one of you tell me? Asutosh Singh, tell me, is it an automated instrument? Evaporation pan and evaporator. Is it an automated instrument? No. It is just like a container. It is just like a container carrying 1.2 meter diameter. Just it is like a collector what we are using in rain gauge station. Very good, Asif Hussain. So just it is a container placed near to bank, near to source. For example, this is the source located. This is a lake or reservoir for which we need to measure evaporation. You want to measure evaporation from this lake, reservoir or a catchment. Consider this is a reservoir. Okay, consider this is reservoir. You want to measure evaporation from the reservoir. Now you are filling water in the evaporation pan up to the stipulated level, particular level. Take this stipulated level is taken as A. The same water in the reservoir is filled into evaporation pan. Whatever quantity of water, whatever quality of water, same quality, same impurities as it is. From reservoir you have taken water and filled into pan. So this is pan, evaporation pan, you filled it. So in the starting of observation period, you filled up to the mark A. For example, you are conducting experiment for 30 days, 0 to 30 days. On the bank of reservoir, you have placed the pan. Got the point? At the bank of reservoir, you have placed the pan. 30 days, you left it to atmosphere. Whatever forces acting on this reservoir, solar radiation, same sunlight is falling down. Whatever sunlight falling down on reservoir, the same sunlight falling down onto pan. Whatever wind velocity, whatever vapor pressure deficit, each and every atmospheric force is going to be acting as it is similar to reservoir, similar to pan. Now after 30 days, clear, after 30 days, You have taken the pan and you have observed that on the 30th day, you have observed that there is a decline in water level. For example, I am saying there is a decline in water level. So how much volume of water is declined? So this is A, you filled up to this level, but water level after the 30th day is at B. So this much quantity in a volume, A to B, some volume of water is evaporated. What happened? This A to B volume, what happened? Tell me. A to B volume, what happened? Tell me. This is get undergone evaporation. This volume of water is get undergone evaporation. Now how can you measure evaporation? Now you take depth of water evaporated from pan. Depth of water evaporated from pan. Are you measuring with scale? Are you measuring the depth of water evaporated from evaporation pan using the scale? Are you measuring using the scale? Asif? Very good, Ramakrishna, very good. You are not measuring the depth. So you are first measuring volume of water evaporated from pan, volume of water, difference between, tell me, difference between A to B. Volume of water loaded difference between A to B divided by area of pan. So that is exactly what depth of water evaporated from the pan. That is equal to how much volume? You are measuring this volume. This volume and area of the pan. Because pan diameter we know. Pan diameter, you can take diameter of the pan 1.2 meter diameter. So this much volume of water, A to B, that much volume of water getting evaporated from pan with a diameter of 1.2 meter. So how much depth we can say now? Volume of water difference between A to B by area of pan. Is this actual evaporation? No. This is pan evaporation EP. This is called pan evaporation EP. Pan evaporation EP is equal to volume of water difference between A to B and area of pan. Jai Hind, Puneet Patak, thank you very much. Now EP you got. What you require? Do you need evaporation from pan or reservoir? Evaporation pan from the pan or from lake, from source? So we have to estimate actual evaporation from source. Your source may be lake, your source may be reservoir, whatever the condition you can take. You take it, your source, whatever your source, you can consider it actual evaporation from the source. We can write down the formula, actual evaporation. EA is equal to, this is actual evaporation, what we are writing? EA is equal to EP into CP. EP into CP. Very good. Ramakrishna, pan evaporation is restricted area. Pan evaporation is in only restricted area of pan. Clear? 1.2 meter diameter containing pan. We are multiplying per unit area. Got it, Ramakrishna? We have calculated per unit area, then multiplied with pan coefficient. What is CP? CP is pan coefficient. Coefficient of pan. pan evaporation is more than actual evaporation, because that is a restricted area. We are imparting forces into small area. So pan evaporation is going to be higher than actual evaporation. Ramakrishna, you got it? In a small container we are restricting, but in a wide area it is going to occur. Na? In such a case, you are applying values from a small container from here to a huge area of reservoir. In such a case, forces acting, all these things will be different. That difference will be taken in terms of pan coefficient. Avijit Chakravarti will tell you. I will tell you, first you write down these formulas. Case 1, case 2, case 3, case 4. 4 cases are there. How volume difference is estimated, I will tell you, Avijit Chakravarti. Now, pan coefficient is equal to 0.8 for IS class A pan. If you are using Indian standard class A pan, pan coefficient is 0.8, and that is 0.7 you can take if you are using US class A pan. Clear? If you are using Indian standard class A pan 0.8, US class A pan you can take pan coefficient 0.7. Again, pan coefficient is 0.75 for Colorado sunken pan. For Colorado sunken pan 0.75, 0.78, 0.78 for US Geological Survey, USGS, US Geological Survey floating pan, USGS floating pan, pan coefficient 0.78. So depending upon what type of pan you are using, you can multiply pan coefficient. Now, that is EA is actual depth of evaporation. It is not volume. No? Actual depth of evaporation happened. Actual depth of evaporation happened from source. That is EA. Volume of water evaporated from source. You need volume. No? Volume of water evaporated from source. So whatever EA you got, EA is related to actual depth of evaporation. Now volume of water evaporated from source, that is equal to actual evaporation into area of source. Actual evaporation into area of source, that is volume of water getting evaporated from the source. So EA we know it, EP into CP. So EP into CP into area, that gives volume of water getting evaporated. So you take area in hectares, pan evaporation in meter. Because of that reason you are getting volume of water getting evaporated in the units hectare meter. Hectare meter. So this is volume of water getting evaporated from source, only one single formula. EP into CP into area. But determining EP is not that much easy. You understand? Simply we have taken volume of water from A to B divided by area of pan. But determining EP value is not that much easy. We have different cases to measure EP value. I will tell you. Finished this writing? If you say yes, this is completed, I will tell you 4 different cases are there to measure pan evaporation. 4 different cases are there to measure pan evaporation, I will tell you. Clear? So case 1 we are writing. case 1, condition 1 we are writing. So you are performing observation period, experiment period, measurement of evaporation for 1 month. Throughout the 1 month, no rainfall. No rainfall during observation period. Observation period is nothing but experiment period. No rainfall during observation period. Observation period or experiment period, whatever you can call it. You are observing evaporation from a source for a duration of 1 month. Within that duration of 1 month, there is no occurrence of rainfall in that location. There is no occurrence of rainfall in that location. So on day 0, you have filled the water up to the level. Remember, up to level A, stipulated level, we call it as a stipulated level. Volume of water is filled up to level A on day 0. Starting day of experiment. Volume of water filled up to stipulated level A. And for example, your observation period is T number of days. This is the 0th day. You have done, observation is carried out. T days completed. So on Tth day, what you are observing on Tth day? No rainfall, zero rainfall. No rainfall, zero rainfall. Only evaporation. Rainfall not occurring. So what happened? Only evaporation means water level will be fall down. This is the level where you filled. Now on Tth day, the water level is located. This point, this location. So decline in the water level happened. That decline in water level will take that point as B. You understand it? There is no rainfall from 0 to T days. Water level fall down because only evaporation going to take place. Water level getting fall down, declined. So what is the decline you can observe? How can you measure now? So that A to B difference, I am going to write and represent with a letter Z. Depth of water between A to B. That depth of water between A to B, I am going to represent with a letter Z. How do you know depth of water? Avijit Chakravarti, tell me, how do you know depth of water? So now what you are going to do here? Fill volume of water. You take some volume of water. Take, for example, you are taking measuring jar, 5 liters of water you have taken. Slowly fill water into this. Make it raise up to A. So as you have taken water through measuring jar, you can know how much volume is filled. That empty space is there, na? In that empty space of evaporation pan, you are filling the water. Volume of water added. For what purpose you are adding water? Tell me. For what purpose you are adding water? Volume of water added to make up to A. to reach up to stipulated level A, volume of water added to make up to stipulated level A. Then you take now how much volume of water added. Now you take how much volume of water added. That volume of water added divided by area of pan. Area of pan. That is equal to Z. Volume of water added divided by area of the pan, that is taken as Z. You understand? You are getting depth. In this case, as there is no rainfall, Z is equal to pan evaporation. If rainfall is there, conditions will modify. But here no rainfall, only evaporation. Directly you take Z is equal to EP. Is it clear for everyone? If there is a rainfall, then we can calculate, either add or subtract or do something. Here there is no occurrence of rainfall, only evaporation will take place. So directly we'll consider Z is equal to EP as there is no rainfall. So do you understand now, Avijit Chakravarti? Do you understand how volume of water? Volume of water you are taking using a measuring jar. Take 5 liters measuring jar, fill the water. All 5 liters over. Again take one more 5 liters and fill it slowly. So you understand total from B to A. Total to increase, to raise water level B to A. How many liters required? That number of liters required, you take here volume of water added. That number of liters you take it as volume of water added divided by area of the pan, Z. Then Z is equal to EP because no rainfall. No need to add anything or remove anything. Now this is over. We'll go ahead. Second case. Now we are discussing case 2. Second condition, case 2. What is case 2? Rainfall occurred during observation period. But still there is no change in water level. Rainfall occurred means additional water to be provided, na? Rainfall occurred means it has provided additional water, na? But still there is neither increase nor decrease of water level. Water level is constant. It is up to A. Even on 0th day, even on 10th day. 0th day, starting of experiment, ending of experiment. Starting of experiment and ending of experiment. There is a evaporation takes place, escape of water from pan will takes place. The same time there is an entry of water through precipitation takes place. Both happen. Evaporation as well as precipitation, both occur. Then after T days, whenever your observation period is completed, what we can expect? Generally rainfall occur. So because of occurrence of rainfall, what we are expecting is, due to occurrence of rainfall, what we are going to expect? There may be rise of water level. Due to occurrence of rainfall, we expect that there may be rise of water level. Is it not, Avijit Chakravarti? We'll expect that one only, na Asanta? Due to incoming rainfall water, always we expect the same rise of water. But what happened here? No change. Before and after experiment, water level is at A only. Why this is happened? Any one of you tell me why this is happened, Asif? on 0th day and also on the last day, teeth day. No change, neither decline nor increase nor rise of water level. Why happened? Tell me any one of you. Neither decline nor rise of water level happened. Neither decline nor rise of water level happened. Why? What is the reason? Because, very good Ramakrishna, nice to hear Ramakrishna. No rise of water, no decline of water. No rise of water and no decline of water. Because whatever evaporation occurred into the pond is equal to precipitation. Whatever evaporation occurred into the pond equal to precipitation. Very good Asif. Very good Ramakrishna. Pond evaporation is equal to P. So we take precipitation value from the nearby rain gauge station. Clear? Directly we'll measure precipitation value from the nearby rain gauge station. So pond evaporation is equal to precipitation. Second case. First case, Z is equal to pond evaporation. Pond evaporation is equal to Z. Second case, pond evaporation is equal to rainfall happened in that location. Rainfall happened in that location. Now we are studying case 3. Now we are studying case 3. What is case 3? Rainfall occurred. What we expect if rainfall occurred? Rise. But decline in water level. Your expectations are not happened by atmosphere. Rainfall occurred but decline in water level. Why this is happening? Rainfall will give more water, so water level can rise. Why even after rainfall occurrence also there is a decline of water level? Because tell me any one of you, the amount of I am waiting for your answer. Rainfall occurred but there is a decline. You have given here up to A, stipulated level up to A you have given here. Water level is filled, placed for observation from 0th day to teeth day. Placed for observation period 0th day to teeth day. So this is 0th day. So both evaporation from the pond takes place. Evaporation from the pond takes place. Entry of water into the pond takes place. Precipitation also occurred. Evaporation from the pond takes place and also precipitation into the pond takes place. Both will happen. Both happen. Now after observation period. After observation period. What is going on, Ramakrishna, here? Again water level is at B. Instead of availability of water level at A, instead of availability of water level at A, water level is available at B. No, after 0 days there is a rain, Vasanta. Rain occurred. Vasanta, don't consider after 0 days no rain. No. Rain happened. Rain happened. but the amount of rainfall happened is less than precipitation. Evaporation in that location is more than precipitation. Evaporation in that location is more than precipitation. So, whatever water entered through precipitation, that is evaporated. Whatever water you have loaded into the pan, that is also evaporated. Both evaporated. Amount of water entered through precipitation is getting evaporated. Amount of water loaded in the pan from A to B also precipitated, also evaporated. Both evaporated. So evaporation is greater than precipitation, or precipitation is less than evaporation. This is the reason. Vasanta, you got it. Very good, Asif. Vasanta, you understand now. After 0th day there is a rainfall. After 0th day there is a rainfall. But occurred rainfall is less than evaporation. Occurred rainfall is less than evaporation. That is the reason behind this. That is the reason behind this. Again we can add volume of water because we need Z. To get a Z value, what you are doing? Add volume of water. Add volume of water and make up to A. Add volume of water and make up to A, Z. Z is equal to same formula. Z is equal to volume of water added. Same whatever you have done in the first case, case 1, same. Volume of water added by area of pan. Volume of water added by area of pan, Z. Same case. Add a certain volume of water into the pan. Measure that volume, how much you have added. Then area you will give Z. Then what is EP, pan evaporation now? Shall we take EP is equal to Z? No. Both the precipitation volume and Z. Both will consider. Na? EP is equal to P plus Z. Don't take EP is equal to Z. Third case. The third case, what is final conclusion regarding third case? Third case, EP is equal to P plus Z. Precipitation depth plus Z, depth of water evaporated from the pan, EP is equal to P plus Z. So if you are adding water, you are adding precipitation here. You are adding water, so you are adding precipitation, P plus Z. Good evening, Barik. So understand this. Case 3, rainfall occurred, but there is a decline in water level. Case 3. Now we are going ahead with case 4. We are considering case 4. Rainfall occurred. And there is a rise in water level. Rainfall occurred and there is a rise in water level of pan. Rainfall occurred and there is a rise in water level of pan. So you have taken evaporation pan. The pan water level rises up. Pan water level rises up due to evaporation. So again, this is the pan. You are filling the water up to stipulated level. You are filling the water up to stipulated level. This is the level of water in the pan. This is the level of water in the pan. A to B, A, this is stipulated level A. On 0th day, On 0th day you have plan. So what is happening from 0 to T days? There is evaporation. Again there is an entry of water through precipitation. Both occurred. There is evaporation. Again there is an entry of water through precipitation. So this is the pan. Consider this is point A and this is point B. So what happened now? Tell me what happened to water level? Water level increased or decreased? What happened to water level? Very good, Vasanta, very good, nice. Water level increased. Water level rises. B is on top of A. A to B will take it as Z. Rise in water level, precipitation is greater than evaporation. Rainfall occurred is more, evaporation happened is less. Rainfall occurred is more, evaporation happened is less. Now how can you measure volume now? How can you measure volume now? You are removing the water. Remove water and make the level up to A. Take out some quantity of water from the pan and make the quantity to be present up to A only. Remove water. Asif Hussain. Correct. Very good, Asif Hussain. Remove that excess water in evaporation pan. Take out excess water from evaporation pan and measure volume of water removed. Measure volume of water removed. So now Z is equal to volume of water removed. Z is equal to volume of water removed by area of pan. So what is pan evaporation in this case? What is pan evaporation in this case? EP. Precipitation is greater than evaporation. You have added up to A. Water level rises up to B after observation period on Tth day. But during that entry of some excess quantity of precipitation, that additional volume what is evaporated through precipitation. So in total precipitation, some volume is getting evaporated. So you will consider EP is equal to P minus Z. Case 4, you will consider EP is equal to P minus Z. Clear for everyone? You understand it? 4 cases. 4 cases. Case 1, no rainfall, rainfall not at all occurred, Z is equal to EP. Case 2, rainfall occurred but no change in water level. Water level is constant, EP is equal to P. Rainfall occurred but there is a decline in water level, so EP is equal to P plus Z. Rainfall occurred, there is a rise in water level, EP is equal to P minus Z. 4 cases we are having related to evaporation measurement through pan. Evaporation measurement through pan. So now we'll consider one numerical question. An evaporation pan an evaporation pan of diameter 1.2 meters is observed for 10 days and it was noticed that 8.4 liters volume of water 8.4 liters volume of water to be added to make up to stipulated level. Rainfall occurred is found to be 20 mm and pan coefficient is 0.7 Find actual evaporation depth for 10 days. Actual evaporation depth for 10 days. Find actual evaporation depth for 10 days. So according to this question and data provided, an evaporation pan of diameter 1.2 meter, diameter D, volume of water getting added, volume V, rainfall occurred, precipitation is P. So the meaning of this, rainfall occurred and volume of water added. What condition? Rainfall occurred and add volume of water. Case 3 only. So we are solving the question with respect to case 3. First, Z is equal to 8.4 liters converted to meter cube into 10 power minus 3. 8.4 liters converted to meter cube into 10 power minus 3 divided by area pi by 4 d square 1.2 square. As we need Z in millimeter, multiply with 1000, converting meter to millimeter. You will get a Z value. To convert meter to millimeter, you are multiplying with 1000 to get a Z value. Meter to millimeter. Multiplied with 10 power minus 3 to convert liter to meter cube. Then meter cube by meter square is meter. You are converting meter to mm into 1000. What is Z value? One of you tell me what is Z value. If we get a Z value, then we'll get EP, then you will get EA. Z is equal to 8.4 into 10 power minus 3 by pi by 4 d square. Pi by 4 into 1.2 square into 1000. What is Z value? So no one answering. No one knows Z value. What happened? Asif Hussain, Vasanta, Barik, tell me answer Z. 8.4 by pi by 4 into 1.2 square. Okay, done. So you write down whatever the value you are getting here. You people are busy not calculating. You people are writing the question, I think so still. So after getting Z, what we can calculate? EP, pan evaporation. What is the condition here? Volume of water added to make up to A. Volume of water added. You are adding volume of water into pan to make up to A. So to make up to A, you are adding means what condition you can take? Case 3. Na? Add V liters of water. Case 3. So that in such a case, case 3, EP is equal to P plus Z. EP is equal to P plus Z. So what is EP value? P value? Okay, 7.43. Z value. Adif Hussain, Z value is 7.43. So 7.43 is Z value. 7.43 mm Z value. P is given 20 mm, 20 plus Z 7.43. We can write down EP 27.43 mm. EP 27.43 mm. Pan evaporation. Pan evaporation EP is equal to 27.43 mm. Now what is actual evaporation EA? Actual evaporation EA 0.7 into 27.43. 0.7 into 27.43. That is actual evaporation EA. You understand it? Pan evaporation 27.43, because we are considering case 3. P is 20 mm, Z is 7.43. Case 3 we have taken. Rainfall occurred, water is declined, and so that we have added some volume of water. So as volume of water added to make up, we have added Z with P. P plus Z 20 plus 7.43. Then final answer 19.2. 19.2 mm actual evaporation. 0.7 into 27.43. Asif Hussain has given the answer. Asif Hussain given 19.2 mm actual evaporation. Okay. So this is the most expected model for evaporation pan measurement. Okay. Next we'll consider just a small topic we'll consider here. Transpiration. Transpiration. What is transpiration? Consider this is the ground level. Soil, total soil, subsoil strata, soil strata, root zone of the soil, agricultural land. Now into this soil strata, you have cultivated a plant. You have cultivated a plant. You have provided growth of plants. This is an agricultural land. Now from plant, soil, which part of the plant can absorb water? This is the plant you have been provided here. From soil, the plant is absorbing water. Wherever you give water, you may provide surface irrigation, subsurface irrigation. You may provide drip irrigation, sprinkler irrigation. Water enter into zone of subsoil. That water is absorbed by root hairs of the plant. Then that absorbed water transmitted into the plant to each and every part of the plant body. Will that water stored inside the plant only? Will the water absorbed by the plant will be stored inside the plant only? Plant has absorbed the water. Will that water given absorbed by the plant from subsoil strata root zone stored there only? No. After utilization for its needs, plant releases water through its leaves. Consider this is a plant leaf. The top surface of the plant leaf always appeared to be light green in color. When you consider this is a leaf, the top surface which is exposing to atmosphere is light in color. Bottom surface which is hidden inside in the bottom deep, not exposed to solar radiation, dark green in color. The top is pale green in color, bottom is dark green in color. So that release of water, whatever utilized water after completion of utilization, the water is released on the surfaces of the leaf outside. For this leaves are carrying a special structures called stomata. The stomata are opened whenever sunlight falling down onto the leaves. So this stomata is like this. They will open, release water into atmosphere. Atmosphere means onto surface of leaf. So whatever water absorbed by the plant after completion of its utilization, it is releases through stomata in the leaves into atmosphere. That phenomena of release of water from the leaves, from the plant leaves, using its stomata, that is called transpiration. That is called transpiration. We'll write down. The phenomenon of release of water from plant, the phenomenon of release of water from plant through the stomatal openings, of leaf surfaces, and then water diffuses into atmosphere. Is called as transpiration. And then water diffuses means gone into atmosphere, is called as transpiration. So when this transpiration will occur, is it possible to occur transpiration during night hours? Night hours stomata are closed like this. Day hours only stomata will open like this, release water. So will transpiration is possible in night hours or day hours? Tell me. Transpiration is possible. During. Transpiration is possible during, very important. Very good, Vasanta. During day light hours only. This is important question for AE exam. Transpiration is possible during day light hours only. This is important question for your exam. Transpiration is possible during day light hours only. And it was measured by. Transpiration is measured using Transpiration is measured using phytometer. Remember the word. Transpiration is measured using instrument. What is the instrument? Transpiration is measured using the instrument. The instrument is called as phytometer. Phytometer. The definition and these 2 points are more than enough for your AE/AEE exam related to transpiration. Clear? The release of water from the plant through the leaf stomata is called transpiration, and which is occurring only possible during daylight hours and measured using phytometer. These 3 points are more than enough. And regarding evapotranspiration, we'll discuss in next session. Next session will be on Thursday. We'll discuss it on next evapotranspiration, followed by infiltration also. By this month, I will promise you, I will finish the hydrology AE/AEE sessions. Don't worry. By this month or month end, I will finish hydrology for AE/AEE. That is more than enough for your exam preparation, theoretical questions. And also after, again, before your exam, before what 10 days, 1 week before your exam, I will conduct objective session on hydrology, so that it is easy for you to write the exam. Okay? Then, from 29th September onwards, remember, note down the date. From 29th September onwards, I am going to start Environmental Engineering Unacademy app. It is not a free class. It is a paid plus course. Unacademy app, I am going to start a new batch on 29th September. So what is the difference of Unacademy with other online learning institutes? Very important. Unacademy is providing you live interactive classes. Some other coaching centers are selling recorded sessions in the name of online coaching. Remember, online means live interactive only. Recorded is not online. Recorded is like a movie. You can't interact with the teacher in it. Unacademy only provides you live interactive classes. And also this time, I came with a good offer to you. 6 months subscription 18,000, 1 year subscription 22,500 after using my code Engineering Guru. And in addition to that, free study material. Some coaching centers are taking for study material itself, they are charging you 5,000 rupees. And 2 free online test series. One from Unacademy side and one from my side. Jubair Khan, regarding GS and all those things, you just send me WhatsApp message. This is my mobile number, Jubair Khan. Regarding GS and other preparation, other subjects, I will tell you. You just send a WhatsApp message to me. In a live class, I can't tell you from where to you study. Okay? Now, 2 free online test series are there. One is provided by Unacademy, one is provided by Future Gate Academy, which is mine. I will provide you 1 more online test series to you. So you get benefited 2 free online test series and 1 free study material, full subject study material. If you take it from other market, for this itself you are paying 7,000. Unnecessary now. You pay 18,000 rupees for 6 months or 22,500 for 1 year subscription. You will get this free study material, free online test series. Very important. What is there in Unacademy? The topmost faculty of India who have worked for 10 years or 10 more years previous experience in top coaching centers in India. Now they are teaching on Unacademy. You know myself, KP sir, former faculty of top coaching center in India previously. Now I am in Unacademy. And the second one, RP sir, who is teaching transportation, structures and other subjects. Abdul Rafi sir, who is teaching geotechnical engineering. All the faculty are experienced, taught 150 plus batches for GATE and ESC. So who is having that much experience, tell me? Teaching more than 150 batches is not a joke. So that much experience our faculty is having. Trust our faculty, we are with you till you crack the GATE examination. So this is my mobile number. 8985931112. You can take plus subscription as early as possible because course is going to launch soon. Okay, we'll rock it. So anything regarding your preparation, strategy, timetable making, doubt session, you just WhatsApp me. I will add you to the WhatsApp group. You will get full support from our faculty side. Okay, we'll meet again on Thursday. Again our class is on Thursday. After Thursday, every day continuous sessions I will take till end of hydrology for AE AEE. Okay, thank you one and all.